I'm so excited because we're getting closer and closer to applying the sample to see what wonders of the world that TLC and HPTLC can give to me. All right, so I need to talk about and give you some ideas of how to apply samples onto a plate. Oh gosh, Tracy, how hard can this be? Well, there's going to be some details that we've got to go through and some things that we've got to discuss, especially when it concerns the instrumentation piece of TLC technology that we are using a little bit more and more of throughout the time. All right, so let's kind of clear up this notepad a little bit and let's talk a little bit about the plate preparation before I begin to apply my samples. All right, so number one, I'm going to go through the extraction process of my samples, and I've got all of this taken care of, or someone else has done it for me, and then they are there on the lab counter bench, and now I'm going to go over to them and I'm going to grab them, and I'm going to say thank you for doing all the work, and now I'm going to take over and I'm going to apply them to a plate. All right, so then I kind of truck over to my lab station, and then I've got all of these little bitty kind of sample containers or extractions that are in test tubes or some types of boiling flask or something that I need to apply onto a plate, so that way I can develop and see what's there and what's not there. So the very first thing I'm going to do is, guess what? I'm going to obtain a TLC plate. Oh, go figures. Oh gosh, this is so hard and so difficult to remember. All right, but at the same time, when you obtain a plate, you want to check the plate to make sure that it is the most appropriate version. So for instance, do you need a silica plate? If so, is that what you grabbed? Do you need something with F254 indicator? If so, is that what you grabbed? You've got to make sure that what you are using at this point is the most appropriate plate for your development. There are many, many choices that are out there. You want to double check these choices to make sure that you don't make a little dummy mistake here, because then you're going to have to go all the way back when things don't work out the proper way, and you're going to have to redo it all over and waste all that time and all that effort and all that energy and all that money that someone has sunk into you in order to do that job, and you're going to have to repeat the process all over again just because you didn't double check a label. So double check the plates, please. You got to make sure you use the right ones. When I get the plate, one of the very first things that I'm going to do is down here at the very bottom, about, I would say 2 centimeters or 1 centimeter. That's really up to you, but I normally kind of gravitate to like 2 centimeters, I guess. We are going to take a pencil, not a pen, a pencil, and we are going to draw a start line that is 2 centimeters up from the bottom of a plate. This is how we are going to make our ready, set, go. Okay. So what I normally do is that I measure on one end and I make a mark, and then I go, I would say a couple inches over, and then I go up another 2 centimeters and I make another mark, and then I go another couple of inches and go up and make another mark, and another couple of inches and go up and make another mark. And this way I am ensuring that I'm going to be drawing a straight line that goes all the way across. That is very, very important. So I'm going to constantly measure 2 centimeters or 1 centimeter, whatever you want to use. 2 centimeters is about an inch. That's kind of where people tell you to start. But this 2.54 centimeters is 1 inch. So about 1 inch. But it allows you to draw a straight line all the way across, and your eyes don't go crooked. My eyes go crooked all the time. So I want to make sure that what I'm doing and what I'm drawing is level as I begin to draw this line and before I apply my samples. Very, very important, and I can't stress that enough, all right? So don't measure 2 centimeters only on one side and then be like, oh, well, this is where I'm going to put the ruler, and then just go all the way over. That's not going to work that way, okay? You're not going to draw a straight line by eyeballing it. So I want you to think that you are a contractor or you're someone in construction and you are marking and you're getting ready to cut and you're just double checking your measurements. That's what this is all about. You want to make sure that these lines are going to be level. You cannot use a pen. And the reason is because pens have pigments. And those pigments are organics, and those organics will mix with your solvents, and those organics in the pigments will travel up the plate, and it will ruin your lane travels because very often it can cover up the things that you actually want to measure. So at no point in time should a pen be anywhere near these plates. These are straight up graphite pencils. That's what you want to use, absolutely. All right, so we've got this plate, and the plate is, covered in silica because that's what I want. We've got a 254 plate. That's exactly what I want as well. 254 because I need to see an image under a UV light at the end maybe. So I need that 254. I have a pencil. I've measured 2 centimeters up from the bottom. That's great. And then the other thing that we like to do is we like to go inward. And we go inward because I don't want samples coming in contact with the edges of the plate. And the reason is because we've talked about this in the first lecture. If things experience the sides of a column, let's say, then those things travel and those things are dragged much slower through the stationary phase. Their velocities are different, almost like due to friction, right? So we've talked about this and we discussed this in the very first lecture module that we had together. So because of that, I don't want to go all the way to the edges of these things and apply sample. I want to go inward a little bit. So most of the time, I'm going to go inward like 1 centimeter at least from the sides. So if I go in like 1 centimeter, like right in here is where I would want to start applying samples. And then I would continue to apply samples, hopefully evenly spaced, along the start line until I get to the other side of the plate. When I approach the other side of the plate, I'm going to back off because, again, I don't want the chance of that sample coming in contact with the edges because that is going to start separation and holding things back a little differently than the middle part of the plate is going to do. So do not go to the edges of the plate. They are not meant to go to the edges of the plate. You will never be spotting closer to those edges just so you can squeeze in another 1 or 2 samples onto the plate that you want to develop. You do not do that. That is not very good lab technique at all. All right, so now that I have this idea, keep in mind, it's got a binder. These have been pre-made. I've ordered them. So a binder's mixed into that silica as well. That's kind of what keeps it stuck to the glass. And it can be a glass back or a plastic back or an aluminum back. It just really depends on what I need in order to do my development with. All of that stuff that we talked about before, it's all coming back. It's all coming back. It's all coming back to me now. That was not a very good Celine Dion, but okay. So all of this, remember, G for gypsum. That's kind of what they use for a binder. So the stationary phase is very thin. So we talked about this as well. If I had a hand do a plate, I can do a hand do a plate. That is not an issue. Make a slurry of silica and the gypsum and the binder and some solvent and mix it up and stir it up. Smear it on the surface of a piece of glass. I got it. But the problem is that when you hand do them, they are not even. So the hand poured plates are very often lumpy. And I say lumpy because if you look on the side of the plate, you might actually see some bevels and some dips because you do not spread that silica evenly across the surface of a plate. When they are mass manufactured now, they do. So there's just like a little scraper that we can put onto the surface of these plates, and it just rakes all of that silica across the plate in a very uniform type of situation that we can then take advantage of. So if that is going on, absolutely wonderful. Thank you very much. That's exactly what we need to see. And it just saves me some time. So no one really makes their own hand-poured plates anymore in the lab. We just order them. Even though they're expensive, we just order them. So that's just the way that it is. The level of thickness here of the silica is anywhere between 100 to 200 micrometers thick. So that means that if it is evenly spaced and kind of leveled out and we are ready to build the foundation of the home, it's one of the first things they do to a ground, right? Then this is going to be about 100 to 200 micrometers worth of silica that has been smeared onto the surface of the plate here. All right. So this is, again, while we pre-order them, this is also, a pretty common thing for any laboratory to do nowadays. But this is also a very expensive thing in order to order. And they know they can get by with it because no one wants to do these anymore. So TLC plates, cha-ching, cha-ching, cha-ching. We already did that kind of sound effect back in the day. And that means they are going to be very, very expensive. And these expensive types of plates that we're seeing can range on average of $800 for a pack of 50. That is what we often see in these third-party scientific supplier companies. So Fisher Scientific, VWR, any of these other types of companies, they're going to be very expensive on their plates, if not more expensive, depending on what type of plate that you're ordering. So is this silica, or is it something more specialized? Is this a 20 by 20, or is this a 10 by 20 plate? What dimension are you after? Of course, these prices can fluctuate, absolutely. But this gives you an idea of how expensive these things might be. So we do pay it because we don't want our plates to be all weird and lumpy, and someone doesn't have the technical expertise to pour their own plates maybe, and we're just not going to get very good data using something like that. So again, we'll order them, we'll bite the bullet, we'll pay out the money, and that's just the way that it's got to be. Next up is applying the sample. So now that I've got my plate marked, my starting line 2 centimeters up from the bottom, I've went inward at least 1 centimeter from the edges so I don't go all the way to the outskirts. I kind of keep it in the middle. Now that I've got all of this marked and it's ready to go, and I very lightly touched, that's the thing that I really haven't mentioned yet. So very light touch is needed here onto the surface of the silica. And that means that when I take my pencil and I bear down on this, oh God, did I just say bear down? Absolutely not. You are not going to bear down on the plates. You're not going to put any type of force on the silica, because if you do, you're going to rake it off. And then if you rake off the silica, then why are you even using the plate? Because it's now ruined and you've just destroyed it. That really expensive plate that we just paid $800 for a pack of 50 of, well, all of that's been ruined because you took a pencil and you were too heavy-handed. Very, very light touch. That is what goes on to the plate. So a very fine, light mark all the way across is what you're after here. All right, so once I apply that start line, then how do I apply sample onto the plate? Okay, not a big deal. We can talk about this, and we're going to talk about how I can manually do it. And if I manually do it and I spot it by hand, I'm going to take a capillary tube, and this capillary tube is not like the MP50 capillary tubes. It is not like our boiling point or melting point capillary tubes. Those tubes are closed on one end. We need capillary tubes that are open-ended on both sides. That is the only way that this is going to work. So I want you to think of a straw. So you're going to put your finger on one end of the straw, and this little hollow tube is going to go into the sample. And then here's my little puddle of sample right there. So we're going to put it into the sample, and that allows that sample to suck up in the capillary. Some people will place their dirty little fingers right up here on the very top, and that will just hold the sample in there. If that's what you want to do, then absolutely do it. It does go into the capillary, though. With capillary action, I don't actually need to do that very often. It's just going to automatically suck up in there. That's not a big deal. And then that straw, that capillary tube, is going to hold that liquid in there until you touch it to another surface. And when you touch it to another surface, a little bit of it is going to be sucked out, and then it's going to go onto the plate because that's where it's going to be headed. So you need a capillary that is open-ended on both sides, not closed-end. One open, one closed? Absolutely not. Those are for MP50s. Those are for manual filled tube melting point measurements. Those are for boiling point measurements in the filled tube, but they are not for TLC application. That is not the way that we do this. Okay, so then I go to the plate, and then I'm going to go to my start line, and I'm going to take my capillary tube, and I'm going to go bleep. That's it. Nothing more. And I allow it to dry. So literally like one little bleep, That's it. Nothing more. And I allow that thing to dry. And then I might need to go back to it, and I might need to reapply that little bleep 2 or 3 times. But that's really it. It doesn't take a lot of sample. Like we've said before in a previous video, TLC is very sensitive. And it does not need a lot of sample in order to be imaged or in order to be seen on the plate. And actually, too much sample is worse than maybe not applying enough. Because now what's going to happen if I put too much sample on there, it's going to smear. And if it smears up the plate, I'm going to see a big old blobby thing that looks like that. That's not a spot. I can't measure the middle, the end, or where it's... I can't do any type of measurements with that thing at all. There is too much on there, and because there's too much, it's smeared in your underwear. No, it's smeared on the plate, and I can't allow it to have that much on the surface of that silica. It is not meant to handle large sample amounts. So that's why I'm saying you're going to go to the plate with your capillary tube, and you're going to beep. That's what you're going to do. One little spot, let it dry, and then move on. And then you're going to bleep, 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 all the way across. All right. When you get to the end, and of course, different capillaries for each sample. All right. Do not cross-contaminate. But when you work yourself across to the plate, what you're doing is that you're giving the original types of spots that you have placed onto the plate, you're giving that time to dry. So by the time that you reach the end, there is a very strong chance that all of these solvents that you used in order to get that sample in solution, you have picked very volatile solvents. That's one of the criterias, right? So these things can evaporate off, and they can evaporate off quite easily, and then they leave the component behind. And that's what we're after. That's what we want to visualize. So that is why we often use things that we can maybe take a hairdryer to, or that we can just let it naturally evaporate off of there, because we've got to make sure that those solvents escape and that they do not linger. Because if that spot stays wet and it lingers, then that can actually promote separation to take place already, and we do not want that. So things like methanols and ethanols are great for that particular type of purpose. And finally, when we talk about applying samples onto the plates, I need you to understand that there is a weirdly little discussion that is happening about how can we be more consistent as far as the sample application is concerned, especially if we are manually applying these samples. So the traditional trend now is to use a micro pipetter, and that micro pipetter is going to allow us to control the sample amount that gets applied in total onto those spots as we begin to spot them across the surface of the plates. So micro pipetting, 10 microliters, 5 microliters, 25 microliters, again, depending on the nature of the substance, the component, what is present, how much of it is there. That is kind of the typical range as far as sample amount is concerned. So anywhere between a half of a microliter to, I'm going to say 25 microliters, give or take a little bit. But at the same time, I do want you to understand that we operate on the lower end of this window very, very often. So 5 microliters, 2 microliters, these are very common applications that we are doing on the instrumentation side of the house. And with manual, we can still see it with manuals, absolutely. With manuals as well, when we begin to image these types of plates that we begin to develop. So spotting by hand, again, make sure you use a capillary tube, make sure it's open on both ends. A very small amount is dabbed onto the surface of the plate, and you go very quickly to do that. You allow that solvent to evaporate, make sure it's all gone before you go with a second spot or a second application of that sample on there. And then you can add more as needed. But at the same time, if you want something a little bit more controlled, then a micropipetter is going to be your friend with the application piece of the plate. Once more, the instrumentation can take over. We'll talk a little bit about that later on in the lecture videos, but for now, it's manual, and that's what this video is focused on. So in the next, we'll continue our discussion. We'll keep talking about application, and we'll talk about the differences that's happening on the instrumentation side of the house when we begin to compare these methods.